So hopefully everybody can hear me. I think everything started here too. Just waiting to see a chance to get on. Are looking at section 4.3 from the textbook today. Again, recall if you know about any questions or you have any comments or concerns, you can send me a message via the chat. You can send me an Edsby messaging or send me an email. Checking all of them throughout of Okay, well, let's get started. So, looking at transformations of quadratics. So, just a quick lesson video. Some of the key takeaways is understanding different types of transformation. Quadratic. Shift the graph up and down, left and right, flip it, and you can stretch, press it. So 3 letters we use: A, H, K. In case of K, what that does is it's going to shift the graph vertically. So graph up and down. Value of K is positive, the graph is going to be up. Negative. We have this black line here as our base graph. When we shift that graph up, if K is positive, K value, it actually looks like this. Square plus K. K added after the x squared portion. In that case, positive K, same graph, shifting up, of a negative K, same graph, but it's going to take that same graph and you're going to up or down, up in the positive. In case of H, H is going to cause a horizontal shift, which actually happens inside, the set of brackets with X. The reason why I put the negative on here is because it does backward. Brackets, it's going to kind of work backwards. So in the case of positive H, then the graph is actually going to move left to the negative side of the graph in general. Positive is to move things. Sorry, the negative is going to be negative to the right, positive to the left. H was positive, so 4 or y equals x plus 4. Take the graph, exact same graph, shift it. Sorry, completely blue. That's negative H, minus H. So this one would be, in the case of us adding H, we're going to shift everything left. Taking each point on this graph, this vertex is just shifting over. Point just shifts over number of values. Shifts over. Same idea with if we flip over to letter A does 2 things. First part is look at the sign of A. Positive or negative. Is it positive? Then our graph will go up. Parabola, but got an upwards open. In the case of A being negative, same parabola, nothing changes, shape, flip it, from the vertex. This doesn't have to happen on the actual. It could happen elsewhere. It could have up with a positive A. A is actually flipping text. It's not flipping based on central x-axis. And then the last key thing is a value. A value. We're ignoring the negative sign, positive negative sign. We're just the actual number itself, the absolute. How far is this number? So if that value is less than 1, 5.728, that value between 0 and 1 is going to press graph, widen it. So given our base graph, then widen it. A is less than 0, say A is widen the graph. It's gonna happen, everything's gonna be wider. It's just like you're taking the graph and you're kind of putting it down, and when you put down on it. And then in the case of number greater than 1, graph or stretch out. So you actually put on it, take this and pull it up just together. The A base value is always 1. Can't be 0. A, the base normal values are. Take a look back at that text. A, base values at the vertex. Value start. A value, however, positive, negative, retrocompress, doesn't have a base 0, but a size we have. All right. So if you guys have any questions, note I hear. I did try, and the audio might be stuttery because I changed. Might that back for the missed something and want me to message me. Let me know something. Try not to. You guys do have any questions specific from 4.3 that you want to look at? I had assigned number 1. See. 5, 7. If there's any of those specific questions you'd like to look at, message me on Edsby, send me a message via email, or mind if you or even through the chat here. Let me take a look at a few I think are some questions that'll be got. So I'm going to start with number 1 quick, just how to sketch out these graphs. Textbook. Number 1, when we want to sketch these graphs, axes, y equals negative 3 squared, x squared, y equals negative. Graph same set of axes. What we'll do, I'm actually going to draw a graph for you. Kind of get in graph and then do that. Base graph here. Here, I equals. Now, case of A was I equals two things happening. One, we got to look at the sign of A, negative. Negative A means it's flip graph, axis in this case. X and stretch is one, stretch it. Graph opening. And because we're sketching, kind of exaggerate changes here, I equals squared. Next one was y equals again just the value. Take that graph now upwards because it's positive, but it's wider because that's less than 1 here. So we're going to open upwards, but wider graph. And we're just sketching this, so keeping it kind of accurate. Stretch, compress, shift left, right, up, down, but in general. And the last one was -1 squared. That one out. Same graph as last blue one. Flip it around the so you get something like that. It would be an image of the blue one flipped around axis. And it's only around the axis in this because the text is at. So 2 and 3 are done similar fashion, other than A. You're doing actions left, right, down, effective case. Number 4 asks to number 4 asking us to sketch label at least 3 points on the parabola and transformation from the grab that. So number 4. And then part A, sketch that one in. This is just going to narrow the graph. Y equals 4. Got to list points or label 3 points. One of those is right here. X is right here. And to find 2 other points, how am I going to get some other? Well, sub in some values. Y equals 4. X is 1. Y well, times 4. 1 and 4. So X is Y going to be 4, 15 is 16. That would be catching that with one more there. So got this whole happening. Have to draw the base parabola. Parabola, and then we want to shift that left, right. Oh, there's that, but there's for A. So I have my base parabola. 0 was 1 x. I subbed in 1 value x. So let's try this with one more here for D. Y equals x minus 8 at x minus 8 squared. What that's going to do, graph right text is going to be the same parabola. Same parabola opening upwards. And find 2 other points. Another point, I equals 6. I value 6 is 8. Ten minus. Again, that's going to be points are x. You guys have any questions? Yeah, let me know. All right, so I understand the audio is not working. I'm going to try and fix that for next video. On there's can't settings that I can change. It might be my internet too. It could that is slow. So if you can't understand, I'll free to send me a message, questions you have or something, and that unfortunately might just be my internet itself that's the audio to run properly. Okay. At question number. Oh, sorry. We missed one part, and that was to describe the change. In case of 4A, change was that the graph stretched by 4. The change in that it was shifted right um do part A from 676 number 6 here. Write an equation for the quadratic relation results from each equation. Half of y x squared translated 6 units upward. Shifting the graph up by 6, y equals x squared, our base graph. This is our base graph, and we're shifting it up by 6, so that's a k positive up. Y equals 6 would say 7a. In number 7a, the graph is translated 7 units left. Translating 7 units left, then h inches x. This change the h, so we're going to the left. Positive change plus positive go left, negative. And then in the case of number 8, 8 says the graph is stretched vertically by a factor of 8. So we're stretching the graph by a factor of 8. So in this case, base graph value change stretch 8. And then just quickly, last one here. So number 9, a type of question of grass in the backyard of a house is a square with a side length 10 meters. A square patio is placed in the side length in x by. I'm going to graph that relation. In case of graphing, again, you create a nice graph on your page. Take a second sheet of paper, tick marks here, mark off graph. Actually, positive. I'm going to do everything. Side because area is never going to be that tick marks is actually or no. Yeah. So I can get spaced and tick marks on top. These here. Making a graph. To also use Desmos. There is a quick graph that you could graphing, but let's actually take a look at in Desmos. Back over at y equals for a equals negative x squared 100. So Desmos graph of hundred. It graph, so the area uh, 10. I can actually change the scale of this x-axis. It's only going to be positive areas, so I'm going to throw 10 just to see that axis. Actually, the y-axis looks pretty good. So there is the graph, portion of the graph that you would use, whole parabola there, portion that you for this 100, 0, and 10 and 0. Then if you find the intercepts of this graph, so if you graph the whole thing, 10 and negative 10 are your, what are the intercepts of this graph? 10? Second question. And look at 10 and negative 10. What do they represent? In this case, this is the maximum size of the patio. Patio not be big 10. Why is that? Because in the question again said that the x values x value was representing side length patio. That is the maximum side length 10. In the case of negative 10, anything on the side of the y-axis is not possible. Side length. Part C says, how does the equation change if grass in the backyard of the house with a side length 12? Because 10 was the maximum possible, sorry, the side length that we could get, 12, which would be maximum side length, so we actually stretch out that graph. Compress that graph, so we'd actually be compressing the graph wider. A value graph. And then the final part, for what values of x is each valid? Well, the 10 and the second one. So again, apologize for any cutting out audio. I'll try and correct that for next video. Have any questions regarding any? All right. Have a good day.